Now that we know how to assign oxidation numbers and write half reactions, we are going to be balancing the half reactions. And this is going to allow us to use the balanced half reactions to balance our chemical equations. But section 3 is just balancing the half reactions. Section 4 is actually using those balanced half reactions to balance the equation. So the first step for any reaction that you need to write the half reactions for is to assign oxidation numbers. Sulfur is by itself, so it's 0 on the left. Hydrogen is always going to be +1, unless it's by itself or with a metal. Oxygen is always going to be -2. -2 times 3 is -6, plus I have a 1, which makes it -5, so the nitrogen has to be +5. And then on the product side, the oxygen is part of a compound, so it's going to be -2. I have 2 of those, so that's a total of -4, which means the sulfur has to be +4. And then NO, the oxygen's -2, so the nitrogen has to be +2. And in water, H is +1, O is -2. All right, once we've done that, the next step is to see what is changing. So sulfur is going from 0 to +4, so sulfur is changing. So I'm going to write that half reaction. S0 yields S plus 4. That's a difference of 4 electrons, and those 4 electrons have to go on the product side, which means this is oxidation. And then hydrogen's +1 everywhere, oxygen's -2 everywhere. The nitrogen is going from +5 to +2. So now I have N +5 yields N +2. The difference between +5 and +2 is 3, and that's going to have to go on the reactant side, which would be reduction. Now the problem we have here is I have 3 electrons being gained and 4 electrons being lost. All of the electrons have to go somewhere, and the totals must be equal. So now we're going to look for the least common multiple among my electrons. So the least common multiple of 3 and 4 is 12. So to get to 12 electrons, I need to take this whole sulfur half reaction and multiply it by 3, and the whole nitrogen reaction and multiply it by 4, so that I have a total of 12 electrons being gained and 12 electrons being lost. So section 3, you're doing the exact same thing you did with section 1, writing the half reactions, except you've got to assign more oxidation numbers to figure out what's being oxidized and reduced. But then you're multiplying the entire equation by whatever coefficient you need to, so that the total number of electrons gained is equal to the total number of electrons being lost. Looking at this equation, if we only look at the number of atoms, it looks like it's balanced. We have 1 tin atom on the left, 1 tin ion on the right, 1 silver ion on the left, and 1 silver atom on the right. However, if we think about conservation of charge, the total charge on the left-hand side is +1, and the total charge on the right-hand side is +2. So the law of conservation of matter is conserved, but not the law of conservation of charge. So in order to balance this, we are going to use half reactions. So we're going to start off and write the half reaction for tin, Sn0 to Sn +2. That's a difference of 2 electrons, and they need to go on the product side. And then we have Ag plus becoming Ag0. That's a difference of 1 electron, and that's going to go on the reactant side. So now I have 2 electrons being lost and 1 electron being gained. The least common multiple of 2 and 1 is 2, which means I need to multiply the first reaction, half reaction, by 1, and the second half reaction by 2, just like we did in the previous example. Now, this 1 will distribute to everything in the equation, not just the electrons. So I know that I should have 1 tin atom and 1 tin ion in the equation. And the 2 distributes to everything in here, which means I should have 2 silver ions and 2 silver atoms. Once I do that, if I go back and check, the total charge on the left-hand side is now positive 2, and it's still positive 2 on the right-hand side. And then double checking the law of conservation of matter, I have 1 tin on the left, 1 tin on the right, 2 silvers on the left, and 2 silvers on the right. So now it is balanced with respect to both mass and charge. Step 1 is always going to be to assign the oxidation numbers. So we know hydrogen is +1 in a compound, sulfur is -2, hydrogen is +1, oxygen is -2. We have 3 oxygens, so that's -6, plus a 1 gives me -5, so the nitrogen has to be +5. And then the sulfur on the product side is by itself, so it's a 0. The oxygen is a -2, so the nitrogen has to be +2. The oxygen's -2, and the hydrogen is +1. Now I need to identify the things that are changing, which are going to be the sulfur and the nitrogen. So now I want to write those half reactions, and I have S -2, arrow S0. That's a difference of 2 electrons on the product side. And then nitrogen +5 yields nitrogen +2. That's a difference of 3 electrons, and those need to go on the reactant side. Alright, so I've got 2 electrons and 3 electrons. The least common multiple of 2 and 3 is 6, which means I need to multiply the first reaction by 3 and the second reaction by 2. So again, this 3 is going to distribute to everything in there, which means I need to have 3 sulfurs. So on the left, the sulfur is part of H2S, so I need to put a 3 in front of that. And on the product side, it's the S0, so I need 3 sulfur atoms there. Now I'm going to look at the nitrogen. The 2 distributes out, so I need 2 n plus 5s, which would be a coefficient of 2 there, and 2 n plus 2s, which would be a coefficient of 2 there. So I know that that ratio of sulfur to nitrogen needs to be constant, so I don't want to change those, but the half reactions didn't tell me anything about the water. So I still need to go through and balance the water by counting up atoms. So if I look on the left side, I have 6 hydrogens there, 2 hydrogens there, so that's a total of 8 hydrogens on the left, which means that this should be a 4 on the water on the right. And let's double check the oxygens. I have 6 oxygens there. I have 4 in the water and 2 in the NO, which is a total of 6. When you're done, double check everything, make sure everything is balanced, which it is in this case, so we're all done with this one. This example is going to be the hardest one that I could possibly give you, so if you're having trouble, that's okay. Now, again, the first step is always going to be to assign oxidation numbers. So we know that K is +1, oxygen is -2. I have 7 -2s, which is -14, plus 2 +1s, which brings me to -12. So the 2 chromiums have to be +12, which is going to make each one +6. In the HCl, H has to be +1, which means Cl is going to have to be -1. The K has to be +1, so the Cl is going to have to be -1. Alright, the Cl in CrCl3. Chlorine has several different possibilities for the oxidation numbers, but the only negative one is -1. And since chromium is a metal and has to be positive, that means the chlorine is going to have the negative charge. So the chromium, since I have 3 -1s, the chromium is going to have to be +3. Here the chlorine is by itself, and then water, hydrogen is +1, oxygen is -2. Now, identifying what is changing. I've got K with a +1 on both sides, so the K is not changing. The CR has a +6 on the left and a +3 on the right, so that's going to be one of mine. So CR +6, arrow CR +3. The difference between +3 and +6 is 3, so I need 3 electrons, and those are going to go on the reactant side. Now oxygen, I've got -2 everywhere on both sides. Hydrogen is always +1, and chlorine here is -1, and over here it's 0. Now the trick on this one is that I also have some chlorines that are not changing charges. So we're going to need to pay careful attention to that when we use these balanced half reactions to balance the equation. But writing the half reaction is the same. We're going to do Cl -1, going to Cl 0, and that's going to be a difference of 1 electron. Now, the least common multiple of 3 and 1 is 3, so we're going to start off multiplying the first one by 1 and the second one by 3. But when I look at the Cl2s up here, the chlorine by itself is 2 chlorines, so there is no coefficient that I can put in front of Cl2 to have a total of 3 chlorines, which means I'm going to need to double the chlorines and the chromiums. So let's look at the chromiums first because they'll be a little bit easier. That 2 gets distributed to everything. So that tells me I need 2 Cr +6s. But there's already a subscript of 2 there. So to have 2 Cr +6s, I just need a coefficient of 1. Now you don't have to write the 1 in, but I recommend that you do for these so that you know that you've already dealt with that compound in the half reactions. And then on the product side, I need to have 2 Cr +3s. There's no subscript on the Cr here, so I need to put a coefficient of 2 in front. Now, looking at the chlorines, 3 times 2 is 6. That 6 is going to get distributed, so I need 6 Cl0s, and I need 6 Cl -1s that are reducing to Cl0s. So if we start with the Cl0s on the product side, I need a 3 there in order to get the 3 Cl0s. But not all of the Cl's are actually being oxidized. So I'm not just going to stick a 6 up here because I need to account for these Cl's that are not being oxidized as well. So I'm not going to do any more of the coefficients based on the half reactions. I'm going to do it by counting. Now, usually saving water till the end is going to be the best idea. So in order to figure out what goes in front of the HCl, I already know how many chlorines are in this compound and over here. This is the only one that's different. So I need to look at the reactant side, and there's 2 potassiums over here. So I know I need to put a coefficient of 2 in front of the KCl. Now I'm going to count up the chlorines, and I have 6 here, and 6 here, and 2 here, and 6 plus 6 plus 2 is 14, which means I need a coefficient of 14 in front of the HCl. And now all I have left is the water, and I have 14 hydrogens on the left. In order to get 14 hydrogens on the right, I'm going to need a coefficient of 7 in front of the water. And then double check with the oxygens. There's 7 oxygens on the right and 7 oxygens on the left. So that one is going to be balanced. All right. Now I want you to try, you should be able to get all of the balancing the half reactions from section 3. It's exactly like we did in section 1, just multiplying by something. And then I want you to do as good as you can on the using the half reactions to balance the equations. Try all of them, and when I get back I can help you out with any that you're having difficulty with.